Hello friends, class FYBSC, semester 2, subject electricity and magnetism, paper 2, chapter 5, magnetic properties of material, lecture 5, hysteresis law, the relation between B and H. As we know, B means magnetic flux density and H is magnetic field strength or intensity. The relation between P and H in ferromagnetic material is complex, as we know previously. It is often non-linear and it depends on the ferromagnetic specimen. Whatever the specimen or the material which we use for this experiment, okay, according to that we get such a type of nature. Okay, actually when we see this figure, then it shows the behavior of a material as we take through one cycle of magnetization. One cycle of magnetization. We have to see how the one cycle of magnetization is there in next part. Looking at the graph, if B, that means magnetic flux density, see, this B is measured for various values of H, and the result is plotted on the graphic form. Then the graph will show this loop, see here, this is the loop, this loop, and this loop is called hysteresis loop. The magnetic flux density B is increased, see here, if we see this magnetic flux density increased when magnetic field strength, see, this goes on increasing when magnetic field strength H increased from this Z. Along the x-axis this is H and along this y-axis it is B. This we have to note. With increase in magnetic field again, see here in the graph. Now this increase, okay, with increase the magnetic field there is an increase in value of magnetization, okay, or magnetism, and finally reaches at the point where what we get a saturation. This point A is called saturation point. And this case, whatever this B is now constant, this dotted line shows the value of constant B. This is constant. Now this is saturation. After that, there is no increase in B. There is no increase in B. This we have to note. With decrease in, now no increase is there. Therefore, we decrease this magnetic, or we can say that value of magnetic field. Okay. If we decrease it, then it decrease in the value of magnetism. See now next from A to like this B. Okay, that means this is a decrease in magnetism. Okay, but at the point B, what happens here? This value of H is 0. Okay, value of H is 0. Now substance or a material retains some amount of magnetism is called retentivity. That means even after this H is 0, okay, there is B, magnetic field is there, therefore some magnetism is there, okay, and some amount of magnetism is there, and that is called what? Retentivity. This is simply what? Retentivity or residual magnetism. Residual magnetism. When there is a decrease in the magnetic field, see here, when there is a decrease in the magnetic field towards the negative side, see here, this is what? A negative side, okay, now towards the negative side like this, okay, the magnetism also decreases. At the point C, the C, at the point C, the substance is completely demagnetized. Here, this substance is completely demagnetized. See, no magnetization is there. Okay, the force required to remove this force required to remove the retentivity of the material is known as coercive force. Coercive force C. This is the force. Okay, that means this is coercivity. Coercivity. Here we get. That means retentivity of the material. We remove the retentivity of the material due to this force. Okay, and this is at point we can say that where C is here. In opposite direction, the cycle is continued where the point is again at saturation. Saturation in opposite direction. Saturation in opposite direction. Saturation point is D and retentivity point is again E. This is again what happens? The saturation, there further it is not decreasing. Okay. Now therefore what happens? It goes on increasing and up to this it is retentivity. Here again we can say that H is 0. Okay, H is 0 here in this case. Okay, and the coercive force is F. Coercive force is F. Due to the forward, that means again what happens? It goes on increasing and it goes to what? This particular point A. Okay, when we increase this particular magnetic field and like this. Okay, then up to what? A. Okay, due to the forward and opposite direction process. That means there is a forward process initially, forward process is there like this. And then again we can say that the reverse process is there. Okay, this is a forward and again this is as a reverse suppose. Okay, due to the forward and opposite direction process, the cycle is complete. That means again we get the saturation point at A. Okay, see here at this point where this magnetic field is constant, cycle is complete, and this cycle is called hysteresis loop. This cycle is called hysteresis loop. This is very important. Okay, and this thing where this graph of B versus H is drawn is simply what happens here for the different value of B, different value of H. This is the graph we get here, graphical representation. This loop we get, and this is called hysteresis loop. This is called hysteresis loop. This thing we have to keep in mind. Then last topic of this chapter, applications of ferrites. Now ferrites are better magnetic materials than pure metals because of their high resistivity, lower cost, easier manufacturing process, and superior magnetization property. Now these are simply the advantages. High resistivity, lower cost, easier manufacturing, superior magnetization, and therefore these ferrites, okay, are used as a magnetic materials. Okay, and pure metals are not used for this. Uh, for the above application, we have to see in the next slide now. Some of the applications are cores of ferrite materials are used in electronic inductors and electromagnets. Okay, that means whenever we have to design the inductors in electronics, the inductors are used uh, frequently. And what happens here? For that, there is a need of core. Okay, and for that core, these ferrite materials are there to uh, Again, we can say that built electromagnets. These ferrite materials are also. Now, second thing is that the ferrite absorbs the microwave energy in only one direction, and therefore these are used as a waveguide. Ferrite absorbs the microwave energy in one direction. Okay, unidirection we can have. Therefore, used in microwave guides. Now these are again used for computer hard drive magnets. Okay, microphones, headphones, loudspeaker. Then next is used as a magnetic head transducer in recording. Okay, for the recording purpose, such a type of ferrite materials are. Then the last application, the ferrite powders are used in the coating of magnetic recording tapes. Okay, that means the material, powder material is actually ferrite powder material is used, and it is coated on, particularly we can say that the tapes, magnetic recording tapes are. These are the applications of ferrite material, magnetic material.